So we are moving on to week 5, which is going to really wrap up our kind of overview of the scientific method and what you need to know for statistics. So we're going to kind of go through a little review today and then make sure that you're kind of set to use this information on the free response questions and everything you do in the future. So I'm going to quickly run through the course page to make sure you really know what is optional. I'm going to kind of preview an assignment that you're going to do on looking at real studies like you have to do in the free response. I'm going to do a quick lesson here to really make sure that you really get the difference between the types of research and summarize descriptive and inferential statistics, kind of just overview of what you did last week. And then there'll be a little quick self-quiz. Make sure you got this down. And so when you turn in, after you watch this video, you can turn in any notes you took. You're going to turn in part for this, looking at the study. You're going to get to pick a study and read it. And you'll do the little self-quiz, which will kind of just be part of your notes. So let's quickly look at the course page so you can see. I was finding jokes here. So, and you're not calculus, you are AP Psychology. And so course week 5. I'm not really going through what you're going to work on. I'm going to cover, I'm kind of always in a week behind because if you can kind of see, I'm having you work on stuff you did in course week 4, and then course week 5, we're moving on to new stuff. And then once I know you have this information, next week's video lesson will be about what you're learning. But so you know, I'm putting in all of these things that say no points. You can see there's nothing here telling you what you need to do. All of this, there's also some of this that was here last week. All of this is optional, all right? And I put it here, you can do it during the week. You can come back to it later in review. It's just a good way to constantly be going back over and practicing questions, all right? So this week in the class, you're gonna do this reflection of scientific practices, right? It's just a time for you to sit and think, what do I really got? What do I really need to keep working on? There is a neurons and neuron firing concept map, which will probably take you 2 days. There's a candy neuron project, and I'm really open to however you want to make your neurons. I just don't want to see them drawn. The directions are all there. There's some extra practice with neurons. You can choose to do it now or later. It's not or never. It's all up to you. And then you're going to start on this nervous systems concept map, but this isn't due till Monday. So I know this is going to take a little while, so start it on Friday and finish it on Monday. So I want to spend a little bit of time in this video just making sure you got everything you need for this Unit 0. And so I'm going to have 3 studies available to you with this assignment. And I'll show you those because I just have links to them. So one is on investigating the relationship between sleep health, depression, social media usage, and adolescence. One is having your cell phone the key to happiness, or does it really matter? And another one is smartphone-free summer camp, adolescent perspectives on leisure context for social and emotional learning. And so you don't have to do all 3. You're going to pick the study that looks the most interesting to you. And here's what I want you to do. So you need to say which of these 3 is it? Is it descriptive research? Is it correlational research? Is it a true experimental design? So the one that you pick, all right? So one question, you're just going to say, is it that? Then you're going to answer the following questions. What question is being asked in the study you picked? What's the population? What's the hypothesis? What sampling method do they use? What are their variables of interest? How is the data summarized? What are the conclusions? I should add one question here. Does anybody remember from the free response? Who can the results be generalized to? All right, we should have that question in there because that was part of the free response. So you pick the study of those 3. You don't have to read it so that you completely understand everything. There might be parts in it you don't get, and that's okay. But see if you can pick out these key things for the study that you pick. All right, so I'll overview this again when I post it on Moodle. So next part, I want to make sure that this is not too confusing for you because I know it's so close. We have descriptive studies and we have descriptive statistics. So we see the word descriptive in both places. All right, and descriptive studies, remember what those are? These are case studies, surveys, and observations. They're just where we're describing, right, if we want to write these in here. So we have them. Descriptive studies are case studies. They were observations. They're surveys. All right, where we're not even looking in this survey here, we're not even looking for a correlation, right? So we have descriptive studies. And then we added last week descriptive statistics. All right, and in descriptive statistics, we're just describing the sample or the data set that we have, right? And we describe data, right? When it's quantitative data, we describe it by using the mean, the median, the mode, the quartiles to talk about the center. So when we talk about how, I think I have a data set here, that's why I have this here, right? So this was from one of those studies, and it's telling you the mean of all of those values. So all the data they collected, it's just a way of describing it, all right? And I can describe it this way, or I'm going to come to this slide in a minute, I can describe it with histograms, right? Not bar graphs, histograms. Histograms are showing all the people in my study, and they're just breaking them down into these groupings. So I can take something and describe the middle, right, where most of the data is by the mean, right? That's the statistical average. The median is the middle data point. The mode is the most occurring data point. The quartiles are showing where 25% occurs, then where 25 to 50% occur, and then where 50 to 75% occur, and where 75 to 100 occur, right? It's just showing you the breakdown. It's all talking about kind of how the center. Then we can talk about how spread out the data is. When we use mean, we use standard deviation, right? And you're going to be able to need to say that the standard deviation is the average distance from the middle. All right, so it's the standard deviation is an average, and we can talk about one standard deviation from the mean, right? I'll bring this chart up here. Here's when I have a perfectly symmetrical distribution, right, a normal curve, the mean, median, and mode all line up, and then the standard deviation it breaks it up perfectly. So here's +1 standard deviation away, +2 standard deviations, +3. And if I say plus or minus a standard deviation, you can see in a normal curve, I'm talking about 68% of all of the data is going to fall in that point. So the standard deviation is helping me see how spread out this is. What is one standard deviation, right? And we can see in different kinds of distributions it might change, but this is when I make it a standard curve, I'm putting all data and saying the mean is at 0. But I could have an IQ test where I say the mean is 100, standard deviation is 15, right? So there's different ways, but the higher the standard deviation, right, the more spread out the data is from the mean. Now sometimes let me go back. The mean and the standard deviation go together and are very good when the data is symmetrical and there aren't a whole lot of outliers. Right? But when there's a lot of outliers, we talked about how the median becomes the better measure. And when we talk about the median, we use the variance to describe not the variance, we use the range, right? We're going to use kind of the highest to the lowest values. And you don't in statistics, there is more to this, but you don't have to know. The variance and the standard deviation are almost the same thing. The standard deviation is the square root of the variance. And this just has to do with if I'm calculating values above and below in a mean, if I find the average of something above and below and above and below, I'm going to get to 0 when I find the average. So this is why we're squaring a whole bunch of differences. But honestly, mathematically, you don't have to know. What you need to be able to do is say the standard deviation is the average amount the value differs plus or minus from the mean. Okay, now I can also, this is how I describe quantitative data, right? Values. But sometimes I also get qualitative when we're qualitative data, meaning we can talk about categories of data here, right? Boys, girls. I can make categories, even if I do age, if I don't say how old you are, but if I do groupings of your age, then I end up with categories, and we can put these categories with graphs. right? So this is feeling happier, feeling unhappier, or both, right? This is qualitative data. The category has no value, but then I can still show percentages in that value. And this is something where, this is why we have pie charts or bar graphs. And then we get to using these histograms. So this is hours spent on social media. And so this is 2 here, so this is 1, so this is probably 30 minutes. So between 0 and 30 minutes, between 30 and 60, which would be 1 hour, right? 1.5, and here's 2 is exactly in the middle, and the number of teens. So it looks like here's 500, so this would be maybe 550, right? And we could add up this plus this plus this plus this plus this, add up all of these little bars, and we'll get a total. And then each of these bars would be the percentage that was in that area. Again, something we deal a lot with in statistics, but we don't have to. What you need to kind of really get the difference is that a normal curve has a mean, and then it is symmetrical on either side of the mean, right? We call these also a symmetrical distribution. You need to know that the mean, median, and mode is the exact same in a symmetrical distribution. A positively skew means the high values are pooling the mean. You see these high values, so this might be something like values of houses. There's some houses that are worth way, way more than the vast majority of houses, right? The mode, the vast majority of houses are worth this much, and these really, really high values drag the mean towards the tail, and the median is shifted a little bit in that direction because we do have most values here, but not completely. So in terms of a positive skew, the mode is less than the median, and the median is less than the mean because the high values are pulling it. In a negative skew, it's the opposite. These very small values are pulling the mean in that direction, so the mean is less than the median, which is less than the mode. Right? So make sure you have that in your notes. All right, so which one of these has the highest standard deviation? Right? We have women, we have men, we have WNBA players. Which one has the highest standard deviation? And if you remember that standard deviation is spread, you're going to tell me that the NBA has the highest standard deviation, right? Because it's the most spread out of the data, all right? It has nothing to do with what's here as height, right? It's how spread out the heights are, the average spread. And since this graph is the fattest, this is going to have the highest standard deviation. Which one has the lowest? We have to kind of see, is it women or men? I think the women is a little bit skinnier than the men, right? And we can see that there's huge amounts of overlap in these distributions, right? So this would show you the overlap. But in general, NBA players are taller than men, and a few women are as tall as the shortest NBA players, if I was reading that graph more. Right, so make sure you understand how mean, median, and mode and standard deviation can be seen in histograms. And what kind of data are histograms used for? Only quantitative, not things that we can put into categories. All right, now we had this idea of, so we had descriptive statistics, and we make sure we understand the difference from descriptive studies. And now we need to make sure we understand the difference between descriptive statistics and inferential statistics. All right, so really, in inferential statistics, we're asking the question, can the results from our experiment be generalized back to the population? Right? And so this really starts with knowing who your population is. And it's very interesting because I don't think most people understand the breakdown of the US population, because whenever they see that there's 13% of a sample from the U.S. population is, say, an African American, they think that's not representing the African Americans in the U.S., and that's not true. That's actually very representative of the total population of African Americans. But anyways, I want to know about this whole population, right? And I cannot ask or put everybody in a whole population in my study. I have to sample, right? And I can either do, how do I know that my sample is representative of this population? Well, there's two ways. It could be random, right? If everybody in my population has equal chance of being in my sample, then I can just randomly pick. But if we're imagining our population as the United States or teenagers in the United States, it's very, very difficult to make sure that every teenager has equal chance to be in our study, right? We're probably doing our study in a certain place, right? So I can't guarantee that everybody in my population has equal chance. So I try to have a representative sample, right? So I try to make sure at least if this population, if I can only get to people, like let's say in New Jersey, I want to make sure the people in my sample, since they're only from New Jersey, are at least representing the percentage makeup of the rest of the country, although that still would have its limitations. Okay, so, and this is, but representative or random samples are better than bias samples. Bias samples are like, whoever's in my college classroom, bias samples. Bias samples is whoever I can find on the internet, bias sample, right? So I want to at least find people who are represented, and my sample should represent my whole population. And in general, bigger samples are better than smaller samples, although it doesn't have to be as large as you think. And a lot of times in very controlled studies, they're very expensive to do, so they, to have not that many people is okay. More estimates or studies are better than fewer. So this is why we like to see replication, right? That word, if we see a study done more than once, and this is where meta-analyses come in, because in a meta-analysis, we're going to take all the studies done on a certain topic and try to see, do we see the same groups? Okay, so I have a population. I sample to get my people, right? So that this population is, this sample is representing this population, and then I need to randomly assign to my experimental group and my control group, all right? And when I take my results, so I could describe the sample, by the way, and I could describe what's happening in this group and what's happening in this group. Inferential statistics is when I take these small people and I say back about my population. All right, so that's what I'm really doing. I want to be able to say, I can describe these guys, I can give the mean, the median, the mode, the standard deviation, but when I want to analyze the difference between these two groups to say something back about this population, that's where it becomes inferential. All right, now, I got 2 more slides, yeah. Last real big idea is this idea of statistically significant. And if you were in my AP Stats class, we spend all year getting to this point, and you get a couple of days. But what we're trying to say is, how likely is the control group different from the experimental group by chance, right? So sometimes 2 groups, like if I just, these are just descriptive statistics, they're just histograms, right? And I don't really know if these groups are different from each other enough to say they couldn't just have happened, right? And so this is where we run a test of statistical significance. And you don't have to know how to run the tests. You just need to say if 2 groups are statistically different, meaning that the chance of it occurring by chance alone is less than 5%, right? That p-value of 0.05. If it's less than 5%, then you say the results are statistically significant. But at the same time, even things that are statistically significant may not be practically significant. And I'll give you an example. For every child you have, there is a statistical difference between their IQ, statistically significant at 1.5 points lower. So the second child has an IQ 1.5 lower than the first, the third another 1.5. We see this when we look at families, right? And it is statistically significant, meaning that they find this value. But it's not very practical or meaningful because when I measure IQ, there's a range of values that I would expect to find if I re-measured the same person's IQ. All right, and that usually is plus or minus 5, 3, depending on the age of the kid. All right, so always ask yourself, does something really matter even if you see it as being statistically significant? All right, so can correlational research be descriptive or inferential? And a lot of this down here I'm not really using, I'm using it in the class, but the question just simply is, if you are trying to take information, right? You're not doing an experiment, but you're trying to take information from your population. You gather a sample, and then you want to ask yourself, does that go back to the population? Then it is inferential, right? But making the scatter plot itself is just descriptive. I'm just describing the data between, say, depression and phone use, right? So I'm not necessarily running it, but I can ask myself, Pearson correlation, so this is just correlational values between them, right? But as soon as I want to make a statement about the population, it is inferential. Okay, last thing for you to do in the video before you get to the research assignment for this week is just take a minute, pause the video, right? I think I have correlational coefficient twice, which you don't need. See if you can do this little Venn diagram, right? Is it a correlational study or an experimental study? What fits where? And after you have moved or after you've written this down on your piece of paper, then hit re-go to play again, and you can check your answers here. So with this assignment, you're going to have watched this video, you're going to have completed this little Venn diagram, and then you can go back to this slide and I'll have the directions. You pick a study and you answer these questions. Thank you very much. I hope this was useful as a good review and that you're ready to move on to Unit 1, the biological basis of behavior.